Okay, YouTube, in this video we're going to be focusing on adding and subtracting fractions, but most specifically fractions that we refer to as what we call complex fractions. So complex fractions, let's go ahead and start by defining this. It has nothing to do with the set of complex numbers, these things right here. It has more to do with the fact that they're just complex, man. So that is to say that we define a complex fraction as being a fraction that contains a fraction in its numerator or in its denominator. So a complex fraction essentially is a fraction within a fraction, and a complex fraction can be simplified using either of these methods that we see here. And so we're going to outline a couple of methods, but most specifically we're going to favor one over the other. So let's take a look at what these are. Method one, essentially, it says that if necessary, what we could do is simplify the numerator and denominator by writing each as a single fraction, and then divide by multiplying the numerator by the reciprocal of the denominator. So that is to say that looking at something like example 6 here, if we wanted to do this, one way to do it is just to go ahead and if we have, I guess, fraction being added to a fraction in the denominator here, we're going to do this first. We're going to do this first. And so by doing this first, what we end up with is a fraction on top and a fraction on bottom. And according to what we see up here, we can just go ahead and multiply by the reciprocal. So the way this looks is we're going to do our work here for the denominator kind of off on the side. So we're going to write denom. Just a little list here. So denom, we have this right now. We have 1 over x plus 4. And this is being added to 2 over x. So with respect to adding these together, let's recall that we want to first of all find the least common multiple between these two denominators after factoring them. So because we don't need to factor our denominators here, we can see that the least common multiple would be the highest power of any of these factors in either of the denominators. So we have x plus 4 to the first power is one of them. And we say also that we have x to the first here. So our least common multiple between the denominators of these, well, what that means is when we do this, we're going to find a least common denominator between these by multiplying each of these fractions by anything in the least common multiple that they don't already have in their denominator. So that is to say that over here we already have an x plus 4, which is on our list. We just need an x. So we're going to take the top and the bottom here times an x. And over here where we have 2 over x, well, we need the x plus 4. So we're going to take the top and the bottom times this x plus 4. So what we end up with here is this new expression that would be over the common denominator x plus 4. And what we get is here 1 times x, so x plus 2 times x plus 4. So this 2 times x plus 4 here, let's go ahead and simplify the top and the bottom of this. It looks like what we get here is x plus 2x plus 8. All over x times x plus 4. And so with this, we can go ahead and simplify the top by combining these like terms, and we finally end up with this. We get 3x plus 8 all over x times x plus 4. So with this guy right here, remember that this is just our denominator. What we're going to do now is we're going to rewrite the original expression, and instead of saying 5 over x plus 4 divided by this 1 over x plus 4 plus 2 over x, we're going to say that it's 5 over x plus 4 over what we see here is 3x plus 8 over x times x plus 4. So the neat thing about this is once you combine the bottom into a single fraction, what we see is that this is dividing by a fraction. And so what we're going to do is we're going to end up multiplying by the reciprocal. So we get 5 over x plus 4. And we're going to take that instead times the reciprocal of 3x plus 8 over x times x plus 4. So now the x times x plus 4 will lie in the numerator, and the denominator will have 3x plus 8. So looking at this, before we multiply these, let's go ahead and factor both the top and the bottom. It looks like that we have a factored expression up over here, and 3x plus 8 share no common other factors than other than 1. So what we're going to get here is that the x plus 4's cancel out, and we get left with this, 5x over 3x plus 8. And so this is our final expression here. And one thing that we'll want to note is that x is not allowed to be negative 8 divided by 3. If we were to set the denominator equal to 0 and solve that, we would get that as one of our potential zeros here. Also looking up above here, what else x would not be allowed to equal? We would say that x plus 4, that would equal 0 if x equals negative 4. So we'll amend this as well. And because what we had in the first place was division here, we could also see that this right here cannot be equal to 0. So also our x cannot be equal to 0. So these are the restrictions right here. So less the restrictions and more about let's make both the top and the bottom into a single fraction, and then what we can do is we can multiply by the reciprocal. Okay, for the second part of this then, let's look at our other method here. And reading through this method 2, what it's asking us to do is multiply the numerator and the denominator, okay, by the LCD, or the least common denominator, of every fraction in the numerator and the denominator, and then we're going to simplify here. So what makes this a little bit different, and I guess I like this method here, I gotta be honest with you, but a little bit different is the fact that we're going to try to eliminate some of the fractions that we're working with here. So we have 5 over x plus 4, okay, and this is all over 1 over x plus 4 plus 2 over x. So looking at all of our denominators here, one thing that we want to make sure is that all of the denominators are factored. What we're going to do is look for the least common denominator between all of these, and the least common denominator is the least common multiple between all of these denominators. So looking at all of these denominators, we see that listing out all the highest powers of each factor, x plus 4 happens to the first power up here. It's also only at highest, at most, to the first power down here, and this doesn't even have an x plus 4. So we need one x plus 4 factor here. But we also, looking at all of the rest of our denominators here, this one has an x to the first. Neither of these have an x to the first, so the highest power of x is x to the first here. So our least common denominator is really the least common multiple between these, which is just x times x plus 4. So the way this works is we are going to follow the instructions here, and we are going to take the top and the bottom of this fraction, okay, both of them, times the least common denominator. And so that x times x plus 4, we're going to multiply this on top and on bottom. And so what I want you to see here is that essentially when we multiply this on top and bottom here, we're really just going to be kind of like distributing down here in the basement. But on top, just multiplying these straight across. And the reason why I say this is because these are both over 1. So when we multiply these on top, here's what we're going to end up with here. I'm going to write out my work. On top, we get 5 times x plus 4. And this is all over now x plus 4 times 1. So x plus 4. And on bottom, what we get to have happen here is that we get, now distributing this through, we get 1 times x plus 4. So x plus 4, all over x plus 4, plus this plus sign right here. And now we're going to take this 2 over x times x plus 4. So we get 2x plus 4 here. And this is all over x. So the neat thing about this is it's guaranteed every time to work here. We should get our denominators to cancel out on every single one of our terms that we have here. So what we get left on top of our fraction here really truly is just this 5x that we had remaining. On the bottom of our fraction here, we have this single x right here. So we have x plus, now over here we had 2 times x plus 4. So 2 times x plus 4. And the last thing we're going to do is just really just clean this up here. So we have 5x over x plus 2x plus 8 here. And so we really get 5x over 3x plus 8. And what I want everybody to see is that we end up with the same expression that we ended up with over here. So the idea is going to be either, okay, add or subtract the fractions on top and bottom and get a fraction over a fraction. And from there we can multiply by the reciprocal and reduce. Or what we could do is we could take the top and the bottom of the fraction times the least common denominator of everything in the top and the bottom. And that essentially eliminates your fractions, and you end up with this relationship right here. So in the next video, we'll take a look at just reducing a few more of these. Cheers.